see my friends kicking in the front seat, sitting in the back seat. Gotta make my mind up. Which seat can I take? It's Friday, Friday.
All right, that's about enough of that song as I can take. I'm going to apologize right off the bat for the music selection on this one. But I'm giving a shout out to my good friend Mr. Sullivan. He is a huge Rebecca Black fan. Bet you didn't know that about him. Doesn't look like it, but he is a monster Rebecca Black fan. And he loves this section. 1.2, we're measuring segments. So we're all about segments. This is Mr. Sullivan's favorite joke as well. So this could be a little painful because I don't think it's that funny, but I told him I'd throw it in there. Hopefully you read it. What's the geometry teacher's favorite fruit? It's an orange. Why is it an orange? Because it's full of segments. A good one, Mr. Sullivan. I love it. It's full of segments. So what are we doing? Are we measuring orange slices today or orange segments? No, we're looking at segments like from last section. Remember, a segment is just an endpoint connected. It's the part of the line between two endpoints. So we're going to measure these. So let's take a look at this. There's some real little subtle differences here. If I look at the ST and ST, these are both referring to line segments. So when I refer to this, ST with the bar on top, I'm actually referring to this. From S to T, all the points in between there. So I'm actually referring to the line segment. So that is what it means when the bar is on top. What if there's no bar there? Now I'm actually looking at the distance. What is the distance? So this is where the measuring comes in. How far is it from 4? I'm sorry, these are negatives. The negatives did not show up very well. Let me throw them in there. How far is it from -4 to +8? So you can count these. From -4, it goes 2, 4, 6, 8, 10, 12. So the distance between these 2 points, or you can subtract them, 8 minus -4 is what? It is 12. So if I'm talking about 12 units, centimeters, millimeter, inches, feet, miles, whatever it is, when I'm actually talking about the distance, I drop that bar on top. So I'm talking about how long is it? There is no bar on top. So kind of a little subtle difference there. Fantastic. So let's start to use that. How does it come up? Another little subtle difference I want to clear up before we get too far into this is equal versus congruent. So congruent means they're the same. So congruent is like, oh, that's the same. Well, doesn't equal also mean if they're equal, they're the same? Yes, they're kind of the same thing, but just like there's a subtle difference here. If I'm looking at this triangle, it says the distance from A to B, so it's referring to A to B, but it's saying it's 4, so they're saying this is 4 centimeters. B to C is 4 centimeters, so they're talking about the distance. We can say they're equal. We can say AB equals BC because they're the same distance. It's just like saying 4 equals 4. So there's no bar on top. But if I come over here, and this is a new word here, isosceles, it just means two sides of the same. So I'm saying this segment equals this segment. So I put this little dash here to show that they're the same or that they're congruent. So this little bar means they're congruent. So what I'm saying is segment AB. So I don't know how long it is. I just know from A to B is congruent. So that means the same as equal. They're exactly the same from B to C. So don't freak out. We're going to start marking things congruent. When we mark line segments congruent, we're going to put these little dashes here that shows they're the same. I don't have to actually find the distance. So we're going to do a little bit of both. We're going to find some distances this section. We're also going to come over here and just say, oh, this guy's congruent to that guy. Very cool. Let's get everyone's favorite, some vocab. So only 2 words this section. Whew. A lot less than last time. We need to know what a midpoint is because it deals with segments. So a midpoint is the point that divides a segment into what? It divides it into 2 congruent segments. So that's what a midpoint does. It takes one segment, divides it into 2 congruent segments. Okay, cool. Can we draw a picture of it? So I already put this out for you. A is the midpoint of CT. So let's draw a picture. So I know I've got this line segment CT. So CT, and I'll draw it in as straight as I can. And A is the midpoint. So what does it do? Here's A right here. Boom. Oh, and it spells cat. Isn't that cute? Like Timmy Cat, like Mr. Kelly, Timmy Cat. Anyway, A is the midpoint. So what happens? This is congruent to this. So I've marked them to the same. So that's the picture. Now I know it's the midpoint because I know this segment is congruent to this one. If you want to write it out, you don't have to write this down. But I'm really saying CA is congruent to AT, and I know that because A is the midpoint. Awesome. Very good. How about a segment bisector? So let's think about what this means. We know what a segment is. Bisector means like it cuts it in half. So it's very similar to midpoint. Let's look at this definition. It's a point, a line, or array that intersects a segment at Where do you think it's going to intersect it at? It's going to intersect it at its midpoint. So if it goes through the midpoint, we call it a bisector. It's cutting it in half. It bisects it. So let's take a look at this crazy sentence. This says ray KE is the segment bisector of segment JO. So let's draw JO. And yours doesn't have to look exactly like mine. As long as you got a line segment somewhere, I don't care what direction it goes. I've got JO. I've got this segment bisector at KE. So I know the segment bisector has to go through its midpoint. So let's draw its midpoint. It's got to go through there. And if it's a midpoint, these are congruent. And it's a ray KE. If it's a ray, it starts at K. Oh my gosh. I almost put the wrong letter. It starts at K. And it goes through E. So it goes through E like that. So you can make your ray go any direction you want, but I've got JO as a line segment, two parts are congruent, and it's got the ray. So we say this ray is bisecting this segment. So pretty huge vocab here coming up. If you ever see a bisector, it cuts it in half. All about cutting this segment in half. Very cool. All right, let's take a look at the next one here. So this is kind of like the proofs we started doing, where I'm going to give you a given and then we're going to find some information. So this is kind of getting this rolling here. So I give you that O is the midpoint of the segment DG. So we got this segment dog. Look at that. Love it. Dog. From D to G is the segment. O is the midpoint. So what does that mean? We're going to mark it. This is congruent to this. So we're going to go ahead and mark the picture. Then I gave you some more information. Oh, it looks like from D to O is 6x minus 7. So fill that in. That's 6x minus 7. O to G is 5x plus 1, and we're going to be doing a lot of this for this chapter, kind of filling in what it means. From O to G is 5x plus 1. I'm going to ask you either just to find x, or I'm going to say not only find x, but find the actual distance of a segment. So we're going to kind of do both here, get it rolling. So can we set up an equation to solve so we can find for x? Well, if these two equal each other, if they're congruent, really what I'm saying is, remember, DO is congruent. So we've got this congruent sign, the equal with a little wave on top. Equal sign of the wave on top is congruent to OG. They're congruent. It means what? It means the distance of DO is equal to the distance of OG. And again, you don't have to write this every time, but I'm going to write it just so you know where I'm coming from. DO equals OG. I can see it. The distances are the same, or the segments are congruent. So what does that mean? Well, let's set them equal to each other. DO is what? 6x minus 7. 6x minus 7. OG is 5x plus 1. Now all we have to do is solve this bad boy for x. Awesome. So really we're going to do a lot of solving with variables on both sides. If you need a refresher, check out Mr. Kelly's awesome video on 3.4 solve equations variables on both sides. Check it out. I'm going to refresh real quick, but he'll explain it all in detail. And I checked, it's not Baby Monkey, so you're safe. It's not Baby Monkey. You don't have to worry about that. It's a good video. Check it out. Let's check this out. So how do I solve an equation? What I do is I draw a line right down the middle so I keep things organized. You want to get all your variables on one side, all your numbers on the other. So in this case, I'm going to move all my x's to the left. So here's a 5x I want to get rid of it. So what do? I subtract it from this side. Whatever you do one side, you got to do it the other. So subtract 5x from this side. Boom. What's left? 6x minus 5x is 1x. Bring down that minus 7. These guys cancel each other out. That was the whole point. I wanted him gone, so I'm left with plus 1. Now I only want x's on this side, so how do I get rid of minus 7? Sure, do the opposite. I'm going to plus 7 to both sides. Fantastic. These guys cancel each other out. I'm left with 1x, or just plain old x, equals 1 plus 7 is 8. So I really like this line to keep me organized. I'm going to show it all my examples. It shows me, x's on one side, numbers on the other. So what do I get here? X equals 8. That is what x equals in this problem. Awesome. X can be positive, negative, doesn't matter. It's just part of an equation here. It can be a decimal fraction, doesn't matter what it is, x. Now when I find a distance, this better be a nice positive number for me. So from what is D to G? Well, I know from D to O is what? D to O is 6x minus 7, and now I know x is 8. Awesome. So I'm really saying 6 times 8 minus 7. So you have to solve for x to find that distance. So 6 times 8 is 48. Minus that 7 gives me 41. So I know from D to O is 41 units. I don't know if it's centimeters, meters, miles, I don't know. And if DO is 41, what do you think OG is? We could do, OG, we could do the math and plug 8 in, but really if it's the midpoint, what's it got to be? It also is 41 units. But that's not the question. The question is, what is from D to G? Well, if you look back up the picture, if this is 41, and this is 41, add them together will give me the whole total here. So what is 41 plus 41? It's going to be 82. So really DG is 82 units long. Excellent. Fantastic. Moving on. All right, let's do a little coordinate geometry. What is coordinate geometry? It just means it's on the coordinate plane. Anytime you get this graph and we're going to plot points and do geometry with it, we call it coordinate geometry. So don't freak out. So I start with an easy problem. Plot these points, -5. So go over 1, 2, 3, 4, 5, up 1, 2, 3. Put a little dot. There's A. Then can we do B? -1, up 3. Well, there's B. So I'm talking about this segment right here. Ooh, that's pretty straight. Look at that. Not too shabby. Can you find the midpoint of AB? What are the coordinates? So this is a coordinate. So how do I find it? Well, I can see it. Let me change colors here. I can see it right there. Boom. There it is. What's the coordinate of that point? Well, I'm going over 1, 2, 3, and I'm going up 1, 2, 3. So the coordinates are -3, 3. Awesome. There's the midpoint. Nice. I can see it. What's the distance? We'll just count it up. That's great. What is the distance? I'm going over 1, 2, 3, 4 spots. So AB is 4 units long. That's it. Awesome. So that's a nice easy one. It's like that. Now I gave you one that's not so easy. Why? Let's see why it's not so easy. Let's try it. -6, 1, 2, 3, 4, 5, 6. Down 5, 1, 2, 3, 4, 5 is point C. 7, 3, 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3 is here. And so now I'm talking about this segment. Woo, not quite as straight. Right here. Oh man, well it's diagonal. Now I can't really look at it and say that's the midpoint. And I can't really count them off and say, well yeah, that's the distance. So now I've got a problem. Okay, so I got the segment drawn in there. So I know the midpoint's somewhere on this line in the middle. It's on the middle, but I need these exact coordinates. So I don't know where I drew it there, but I mean, where is it on this line? I know it's in the middle. It's ballpark around here, but I want exact coordinates. How are we going to find that? Well, we're going to need some kind of formula to help us out. So let's get a formula down here. Let's unblock this. Oh my goodness, what is that? Holy cow, there's Rebecca Black, Friday. And look who's driving. Are you serious? I never noticed that in the video. Oh my gosh, Mr. Sullivan is driving. I knew there's always confusion about where to sit. Front seat, back seat, all that confusion. Turns out Sully got there early. He's the driver. Unbelievable. Let's get that out of here. All right, thank goodness, it's taken off. So we need a formula. What is a formula to help us solve these things? Well, let's try it here. Basically, for the midpoint, what we're going to do is it's the average. It's the middle. So how do we do averages? Well, if this is my first point, we call this x1, comma y1. It's just the first point. It doesn't matter. You can call either one the first point. But just this is our, let's say it's our second point. We call it x sub 2 and y sub 2. So it doesn't matter. It just means you have 2 points. What am I going to do? Well, I'm going to say midpoint we use this capital letter M, and I'm going to average them. So I'm going to take my x's and add them together. And then I'm going to divide it by 2. Average means divide it by 2, or however many you have. So that'll give me the x coordinate. To get the y coordinate, I'm going to add my y's and divide them by 2. Does this cool formula work? Well, let's try it. x1 plus x2 would be -6 plus 7 divided by 2. That's the first coordinate. The second coordinate would be add your y's. Well, I've got -5. What do I got here? Plus 3 divided by 2. And so what happens here? You get -6 plus 7. That's going to be 1/2. You got -5 plus 3. That's going to be -2 over 2. And if I reduce that a little bit, I'm going to say it's 1/2 over -1. Does that work? Well, holy cow, look at my picture. I was pretty spot on. If you go over 1/2 and down 1, you're right there at the midpoint. So actually, my guess was pretty good. Fantastic. How about distance formula? Distance formula is a little more intense. Don't freak out though. Really, the distance formula is just Pythagorean theorem. If you like triangles, sometimes I just do the Pythagorean theorem. That's where it all came from, is this. Imagine this is a triangle here. So if I can find this side and this side, I can find the hypotenuse of the triangle. If you're very good with the Pythagorean theorem, you can kind of get that way. So how much did I go up from C to D? What is this side from down here to up here? Well, it looks like I went up 1, 2, 3, 4, 5, 6, 7, 8. And how far did I go this way? Count them up. It looks like I went 13. So really I'm saying Pythagorean theorem says a squared plus b squared equals c squared, or 8 squared plus 13 squared equals that distance we don't know squared. And that'll actually give us the total distance of this. If I do Pythagorean theorem, 64 plus 13 squared, I believe, is 169 equals c squared. Add those bad boys together. I'm looking at what, 220? I hope it's 233. Oh my goodness, high pressure right there, mental math. And then what I gotta do, I gotta square root both sides. So I think the distance of this is gonna be the square root of 233. So if you like Pythagorean theorem, you can do Pythagorean theorem, or here's the actual formula. What I counted in my head, a lot of times I don't like to draw this graph because these points don't fit, they're really big points. So to find the distance, we just solve the quadratic formula for the hypotenuse, and we get this bad boy right here. Everybody loves this one. What do you gotta do? You've got to take your x's and subtract them. So most people put x2 first, it doesn't matter. Subtract your x's, x2 minus x1, and square it. Just like, remember I squared it up here with the 13 is squared? That's my x's. Then do your y's. I'm going to say y2 minus y1 squared. That's how I got 8, really. I was saying I was at -5 and 3. I just subtracted them and got 8. And then I squared it. That's how I got the 64. This is the formula that does it. So this is really how we do it. And how would that look? I'm going to set it up. If we had this formula, I would say x2 minus x1 is really going to be 7 minus, what was x1? -6. And then I'm going to square it. Plus y2 is 3. Oops. Let me erase that. I kind of messed up a little bit. I don't want to comma there, I want to minus it. So 3 minus what's y1 is -5. And the hard part about this is my negatives. I got these double negatives going on here. So I've got 7 minus -6. Remember, that really means plus. So I've got 13 squared plus 3 minus -5. Remember, 2 negatives is change is going to be 8. And that's going to be squared. Check that out. Does it look like Pythagorean theorem? Yes, it is the Pythagorean theorem. So really, this whole time I was saying the square root of this mess. The square root of this mess. So what happens? Well, now I can do the math really quick in my head. I've got 169 when I square them plus 64. And again, you want to square root it, which is the square root of 233. So that is the actual distance. Fantastic. If you want to type in the calculator, type in the calculator. You can get approximation, the square root of that. Okay, here we go. So I pull out the calculator real quick. If you want to approximate, this is cool. We're going to approximate everything to 2 decimals, so round to the nearest hundredth. So if you want to do it, just a quick reminder, the square root sign is right above the x squared side. So if you hit second x squared, there's the square root sign of 233. It's probably going to be some nasty decimal. It is. So we're going to round it to the nearest hundredth. So we're looking at 15.26. The force keeps it at 6, so we're going to say 15.26. So go ahead if you want to. You can say this is really somewhere, and I use this wavy line because it's not exactly 15.26 because I rounded it, but it's really, really, really close. Fantastic. All right, moving on. All right, so what I'd like you to do is I wrote the formula up nice and neat for you, so make sure you have that jotted down somewhere and circled. You can use this. I'll give it to you on the mastery checks and on the test, so you don't have to memorize it, but I want you to be very, 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 very comfortable using it. Go ahead and pause it. Try this one, see how it goes. All right, here are the answers, and blue is the midpoint right here, so hopefully you got -1/2 1, so it hits right there, and it looks good. Double check your answer, plot it. Does it look right? Yeah, so it's probably right. If it looks right, I mean, make sure you're at least ballpark close. Distance, just be careful of the negatives. Just like up here, it's all about keeping your signs. Remember, if you ever square a negative, it's always positive. So this is the biggest mistake right here. -11 is a positive 121. So you always get positives in here. If you don't, you've got some kind of error issue. So the distance from here to here is about 12.53 units. Hope you got the right answer. Awesome. Oh my goodness, there's Mr. Sullivan in his Rebecca Black t-shirt. Love it. His sleeve tattoo. I bet you didn't know he had a sleeve tattoo, did you? I think he got that removed later on. So he says, good luck on your master check. He actually was hoping they would make a song about geometry. We'll listen to it here in a second. He kind of made his own rendition of that. But check out this little flow chart. This is almost like a proof. And it's geometry everywhere. Who knew? Yesterday was Thursday. Today's Friday. We've got a line segment. From here to here is a line segment. Then what do we got? To get to Saturday, we've got a ray. Oh my gosh, this is awesome. Line segment. Line segment, ray. So who knew? Flow charts, geometry, it's everywhere. Good luck on the mastery check. Enjoy the song.
7 a.m. and I gotta do homework. Gotta draw graphs, gotta pi r squared. Gotta plot lines, gotta be parallel. Having lots of fun doing math. Clicking on a non-mechanical pencil. Gotta get down to the bus stop. Gotta catch my bus. I see my friend. Never mind. Adding in the front seat. Protractor in the back seat. Gotta get my math on. It's time to postulate. It's geometry, geometry. Gotta write down my work in. Everybody's copying me in whole. writing down my work, and everybody's copying me. I wish they'd do their own.